this video, I'm going to talk about somatosensation in the peripheral nervous system. Somatosensation refers to senses of the body. And that includes a whole bunch of different senses, but I like to think about 5 senses in particular, which turn out to be really useful for medical purposes, because we can test them on examination. The first of these we call position sense, by which we mean the position of body parts relative to each other. For example, if you close your eyes and somebody lifts your arm above your head, you can feel that your arm has been moved. You don't actually have to see it to know that. Another sense of the body is vibration sense. If we come into contact with anything that's vibrating, we can feel that. We often use little tuning forks when we're examining patients to see if they have normal ability to feel something vibrating. The next sense is touch. I'm going to write that in a different color, and I'll come back to why I'm using these different colors in a minute. Then we have pain and temperature. Temperature. Now let me just write a little R here to represent a receptor for one of these types of somatosensation. Because to be able to sense anything, you need a receptor, something that can detect that type of stimulus. And there are many different types of somatosensory receptors, and we lump them into a few different categories. The first big category of somatosensory receptors respond to physical forces, so we call those mechanoreceptors, because they respond to mechanical stimuli. Mechanoreceptors. And receptors in the category of mechanoreceptors can detect the position of body parts relative to each other, and vibration, and touch. And then there are other receptors for the senses of pain and temperature, which I'll just represent with a big R here. So somatosensory receptors that can detect noxious stimuli that can create the experience of pain, we call nociceptors. Nociceptors. And they actually can detect a number of different types of stimuli that can give rise to the experience of pain. And then somatosensory receptors that can detect temperature, we call thermoreceptors. Thermoreceptors. Now, somatosensory receptors in all these different categories can be found in a number of places throughout the body. One of the big places is in the skin. So here's a drawing of the skin. This is the very surface of the skin with the hair coming out of it. And then here are the deeper layers of the skin. And there are a number of neuron axons entering the skin here in a few different places that will have some of these different somatosensory receptor types. So for example, for mechanoreceptors, in this drawing, there are a couple of mechanoreceptors drawn, and they tend to have these structures on the end. So for instance, right here, this little structure on the end of this axon that's coming into the skin, that's one type of mechanoreceptor, close to the surface of the skin. And here's another type of mechanoreceptor with this structure here at the end of this axon that's coming into the skin. So these are 2 types of mechanoreceptors that can be found in the skin, and there's lots of different types of mechanoreceptors in the skin that sense all sorts of mechanical stimuli to the skin. But there are also somatosensory receptors in the deep tissues, way below the skin here. For example, in this drawing, here's a muscle. This is one skeletal muscle. And in this illustration, they've magnified one somatosensory receptor that's in the muscle. It's this whole structure right here. And this particular somatosensory receptor is a mechanoreceptor that detects stretch of skeletal muscle. So when this skeletal muscle is stretched, this receptor can detect that and send that information back to the central nervous system through neurons. And these types of receptors, like this one in muscle, along with other ones in tendons and in the capsules around joints, are very important for position sense because they can send information back to the nervous system about the relative position of body parts. Whereas some of these mechanoreceptors in the skin, or the tissues just closer to the skin, are often more important for detecting things like vibration and touch. Nociceptors that detect pain and thermoreceptors that detect temperature usually don't have these sorts of structures at the end of an axon that's going to carry that information back to the central nervous system. Instead, they're usually like they've drawn here, where there's an axon coming into the skin right here, and at the end there is no structure. the axon just ends in some uncovered terminals. Let me circle that here. And these are usually called bare nerve endings because they're not covered by any kind of structure like these guys are. And so nociceptors detecting noxious stimuli that can cause pain and thermoreceptors detecting temperature tend to be these bare nerve endings. Now, once one of these somatosensory receptors detects the stimuli that it's specific for, it's going to send that information back in axons of the peripheral nervous system. And these are going to be axons carrying information from the periphery through nerves in the peripheral nervous system back into the central nervous system. So these are a type of afferent neuron carrying information into the central nervous system. And these afferent neurons carrying somatosensory information we call somatosensory neurons. Most of these neurons have their somas in ganglia close to either the spinal cord, or if they're entering the brainstem, their somas will be in ganglia close to the brainstem. And the different types of somatosensory information tends to travel in different types of somatosensory neurons, so that position sense information, vibration sense information, and some of the touch information tends to travel in certain somatosensory neurons, like I've drawn here in blue, while pain information, temperature information, and the rest of the touch information tends to travel in different types of somatosensory neurons that also bring information back to the central nervous system. One of the big differences between these different types of somatosensory neurons is how big their axon is and how much myelin there is on the axon. So that this type of somatosensory neuron, carrying information about position sense, vibration sense, and some touch sense, tends to be in large diameter axons. So let me just draw a couple of lines far apart to represent a large diameter axon. And these axons tend to have thick myelin sheaths. So the Schwann cells that are creating the myelin sheaths on these somatosensory axons tend to be wrapped around with many, many layers so that they're very thick. So I'll just draw these orange circles to kind of represent the thick myelin sheath on this type of somatosensory axon. Whereas these other types of somatosensory neurons carrying the pain and temperature information as well as the rest of the touch information tend to have small diameter axons. So let me just draw a much thinner axon here like this. Let me draw two of these actually. And they're both going to have these thinner neuron axons with a smaller diameter. And then they'll either have a thin myelin sheath, so let me just write some thinner circles here to represent a thinner myelin sheath with less wrapping of Schwann cell membranes around the axon of these somatosensory neurons. Or they'll have no myelin sheath at all. They will be unmyelinated axons. And since axons with a larger diameter and a thicker myelin sheath conduct action potentials more rapidly, these types of somatosensory neurons will conduct action potentials fast. Whereas the somatosensory neurons that have small diameter axons and thin myelin sheaths, or no myelin sheath at all, will conduct action potentials more slowly. That information will get there, but it'll take a longer time to get back from the receptor in the periphery to the central nervous system. And the sense of touch is a funny one, because it travels in both these rapid somatosensory neurons and these slower somatosensory neurons. But what tends to happen is that very precise touch information that we call the fine touch sense tends to travel in the fast somatosensory neurons, whereas less precise touch information that we usually call gross touch sense tends to travel in the slower somatosensory neurons. So in later videos, we'll get more into somatosensation in terms of what happens to this information once it gets into the central nervous system. But this is a general overview of how somatosensation occurs in the peripheral nervous system.